Narrowband IoT is another 3GPP proposal, but it does not operate in the LTE construct. It is based on a DSSS modulation. NB-IoT is a narrowband IoT technology specified in Release 13 of the 3GPP in June 2016. NB-IoT can coexist with GSM, Global System for Mobile Communications, and LTE, long-term evolution, under licensed frequency bands, e.g., 700 MHz, 800 MHz, and 900 MHz. NB-IoT occupies a frequency bandwidth of 200 kHz, which corresponds to one resource block in GSM and LTE transmission 1. With this frequency band selection, the following operation modes are possible. Standalone operation. A possible scenario is the utilization of GSM frequencies bands currently used. Guard band operation, utilizing the unused resource blocks within an LTE carrier's guard band. In-band operation, utilizing resource blocks within an LTE carrier. The NB-IoT communication protocol is based on the LTE protocol. In fact, NB-IoT reduces LTE protocol functionalities to the minimum and enhances them as required for IoT applications. For example, the LTE backend system is used to broadcast information that is valid for all end devices within a cell. As the broadcasting back-end system obtains resources and consumes battery power from each end device, it is kept to a minimum, in size as well as in its occurrence. It was optimized to small and infrequent data messages and avoids the features not required for the IoT purpose, e.g., measurements to monitor the channel quality, carrier aggregation, and dual connectivity. Therefore, the end devices require only a small amount of battery, thus making it cost-efficient. The downlink of NB-IoT is based on OFDMA with the same 15 kHz subcarrier spacing as LTE. Slot, subframe, and frame durations are 0.5 milliseconds, 1 millisecond, and 10 milliseconds, respectively, identical to those in LTE. Furthermore, slot format in terms of cyclic prefix, CP, duration and number of OFDM symbols per slot are also identical to those in LTE. In essence, an NB-IoT carrier uses one LTE PRB in the frequency domain, i.e. 12-15 kHz subcarriers for a total of 180 kHz. Reusing the same OFDM numerology as LTE ensures the coexistence performance with LTE in the downlink. For example, when NB-IoT is deployed inside an LTE carrier, the orthogonality between the NB-IoT PRB and all the other LTE PRBs is preserved in the downlink. Consequently, NB-IoT technology can be regarded as a new air interface from the protocol stack point of view, while being built on the well-established LTE infrastructure. NB-IoT allows connectivity of up to 100K end devices per cell with the potential for scaling up the capacity by adding more NB-IoT carriers. NB-IoT uses the single carrier frequency division multiple access, FDMA, in the uplink and orthogonal FDMA, OFDMA, in the downlink, and employs the quadrature phase shift keying modulation, QPSK. The data rate is limited to 200 kbps for the downlink and to 20 kbps for the uplink. The maximum payload size for each message is 1600 bytes. NB-IoT technology can achieve 10 years of battery lifetime when transmitting 200 bytes per day on average. Here you can see the downlink and the uplink channels. NDSCH peak data rate can be achieved by using the largest TBS of 680 bits and transmitting it over 3 milliseconds. This gives 226.7 kbps peak layer 1 data rate. NPUSH peak data rate can be achieved by using the largest TBS of 1000 bits and transmitting it over 4 milliseconds. This gives 250 kbps peak layer 1 data rate. NBIOT targets latency in sensitive applications. However, for applications like sending alarm signals, NBIOT is designed to allow less than 10s latency. NBIOT aims to support long battery life. For a device with 164 dB coupling loss, a 10-year battery life can be reached if the UE transmits 200 byte data a day on average. As of March 2019, GSA had identified 149 operators in 69 countries investing in one or both of the NBIOT and LTE-M network technologies. 104 of those operators in 53 countries had deployed/launched at least one of the NBIOT or LTE-M technologies. Of those, 20 operators in 19 countries had deployed/launched both NBIOT and LTE-M. 22 countries are now home to deployed/launched NBIOT and LTE-M networks. 29 countries are home to deployed/launched NBIOT networks only. 2 countries are home to deployed/launched LTE-M networks only. 141 operators in 69 countries investing in NBIOT networks. 90 of those operators in 51 countries had deployed/launched their networks. 60 operators in 35 countries investing in LTE-M networks. 34 of those operators in 24 countries had deployed/launched their networks.